Hello, so welcome to your last video of this particular introduction chapter. Your first quiz or quest will be over all of this information. It's not going to be like a traditional test, but it's going to be a little bit longer than a quiz. So when we talk about science, we always talk about measurement. And so it's really important. I feel it's really important that you know how to measure things. And I know you're thinking, of course I do, but we are now taking our idea of measuring and we're using a completely different system. So this may be a little bit difficult and challenging for some of you to think about. We're not doing inches, we're not doing feet, we're doing things like the meter, the centimeter. So hopefully you've heard about these things and you've practiced converting before. If you haven't, that's okay. We will learn that in class in the next few days. In this video, you should be able to identify the 7 base units. I've actually shortened it to 4 since I've made this video last year. So this is a new year. You should be able to apply metric prefixes. You should be able to convert between various base units and distinguish between mass and weight. We are not going to worry about that right now. So that's obviously taken out from this video. So let's go ahead and talk about some things. I had a slide actually that I made prior to this, but I guess I didn't save it, and so now it's not here. But I want to talk about measurement and why measurement is even important. So you should know that a measurement is a quantity that includes both a number and a unit. And I know you've probably dealt with inches, so I'm just going to use that as an example. If I were to look at my leg and say 12, well, that tells me absolutely nothing about what I'm even talking about. Am I talking about 12 inches lengthwise, widthwise? What am I talking about? So it's really good that we distinguish using both a number and a unit in order to take a measurement. Like I said, the number 12 really doesn't give me a reference point. It gives me no value besides the fact that it's 12 of something. So it's a dozen of something. But if I said 12 in reference to a penny, you're probably thinking, oh, maybe she has 12 pennies instead of maybe a penny is 12 millimeters. So that's just an example of what I mean by the unit being very important in that distinguishing that value portion. If you're not given the number and the unit, then there's not enough information to quantify something. And that's all a measurement is to give you that quantification of it, of whatever it is we're measuring. So this very first slide is talking about SI base units. And before we even begin, I want to go ahead and say that we are not using the English system. You probably never even heard of that name for what we use to measure. So the ounce, the foot, the cup, inches, those are all known as the English system of measurement. And we will not use those. Instead, we'll use the metric system, which is the system that's based on all powers of 10, multiples of 10. And it's really nice because we don't actually have difficulty in converting from things. So for example, if I say I have 1 foot, that means I have 12 inches. Now, maybe you know that, but maybe you don't. That's kind of like trusting that we know that conversion factor, but not everybody actually knows that. I could also say if I have 3 feet, equals 1 yard. That's another conversion factor that's like really weird. 2.2 pounds equals 1 kilogram. These are numbers that are not really very easy to remember. So instead we use the metric system because this is all based on powers of 10. So if you know anything about the powers of 10, tens are the ones place, the tens place, the hundreds place, thousands, so on and so forth. And you can go the opposite direction. You can say the tenths place with a th at the end, hundredths place with a th at the end, or thousandths place. And hopefully we learned all this in prior classes and even in math class. But if you haven't, don't worry. I'm going to review that in class. And in my notes, you'll see that I have that in there. We have, oh my goodness, I clearly edited this slide very well because it says 7 base units. Below are the 4 we will use in class. I actually was just going to take out the 7 altogether, but it's okay. There are actually 7 base units. We are only going to talk about 4 of them, and that's 4 is right here. So length, you need to know that the base unit, and what I mean by a base unit is the fact that it's like a consistent unit used within the system, the metric system. It's also representing just one of something. You'll see that there's a difference there with mass. Hopefully, maybe you've noticed that already. But typically your base units don't have a prefix in front of them. So you notice the meter, it's just meter. In comparison to the mass, the base unit for mass is kilogram. You can still convert back and forth from the kilogram, but the kilo is now giving a value. When we get to the next slide, I'm going to talk about prefixes and how we use those things to help us establish different sizes of stuff. Let me see here. The International Systems of Units, that is what SI stands for. That was based off of the French, and so the SI is because in French it's actually Le Système des Unités, or I don't think I said that right, de International des Unités or whatever, but I'm not trying to be insensitive, but I really don't know how to say that. Either way, the S comes before the I in the French version of this, so that's why it's just adapted as the SI units. And SI units do use the metric system, so it's really easy to go back and forth when you're talking about SI units and metrics. They're very much interchangeable. All right, so let's look at this ridiculous slide. Again, I made changes to this table, but I apparently didn't upload the right copy of this PowerPoint. So I'm going to talk about these things, and please don't let this table overwhelm you because it can be overwhelming if you let it get that way. All right, so hopefully we know that everything kind of always starts with 1 in the ones place. That means if I say 5, I just have 5 of something, okay? Now, when we add a prefix to something, and a prefix is a piece of a word that goes before a word. And I've given you all of these examples here. So these are our prefixes in this row. These prefixes now give a value to something. So if I were to say I have a kilogram of something, I have a certain amount of grams. So if I say I have 10 kilo, or excuse me, let's say 5. Let's say 5 just for the sake of easing you into this. If I say I have 5 kilograms of something, that value for kilo is 1,000. Okay, so kilo means 1,000. So if I say I have 5 kilograms, I can also say I have 5,000 grams. Grams would be under this particular one because there's no prefix in front of it. So it would have a meaning of 1. So kilo equals 1,000. That is putting a value to something. The central unit, which is this guy here, it has no prefix and it always indicates 1. I'm hoping that I'm not repeating myself like crazy, but I want to make sure we're understanding that. If you were to go anywhere above 1, you'll notice a couple of things. First of all, the prefixes are giga, mega, kilo, hecto, and deca. Some of these things you've probably heard and you think a lot of, like giga or kilo. And you'll notice that their exponents are all positive. Positive exponents. All right, so these are all positive exponents. Whenever you see a positive exponent, that means the value is greater than 1. It is greater than 1, so 10 to the 0 equals 1. In comparison to 10 to the 1, which equals 10, 10 to the second, 100, 10 cubed, 1,000, and so on and so forth. And that's probably where we'll stick when we talk about our measurements. We'll generally deal with kilo, hecto, and deca. And then on the opposite end of that, or underneath 1, what's less than 1, are these negative exponents. Whenever you see a negative exponent, that means it is a number smaller than 1. And notice here, we have 1/10. So it's in the tenths place with a TH at the end. 1/100th. Another thing I want you to notice is that over here I put 1 decimeter equals 0.1 meters. I could also say 10 decimeters equals 1 meter. That's all saying the same thing there. And we are going to practice this in class. Please, please don't freak out. Don't let this table overwhelm you. I will be giving you another table that's hopefully not as overwhelming and it's actually very friendly to use. The reason why we do this is so that if I were to say, I want you to measure a penny, you're not going to use an entire meter stick to measure a penny. A penny is really small, so you're probably going to use units like millimeters or centimeters. But the base unit or the unit that's always used for length is always meter. So you're going to need to convert from centimeter to meter. So that takes practice. And that's just all we're doing is just moving our decimal place either to the right or the left, depending on if it's bigger or smaller than the base unit. So like I said, this 1 here with no prefix indicates we have 1. We are going away from that in either the positive or negative direction. And on the next slide, I have some practice stuff that we're going to practice. This video is going to be very short. We will spend time in class doing this. If I have to move your quiz from Thursday to Friday, no big deal. Not in a super rush. I do want to make sure that we understand this. Over here, if we look at kilo, it says the meaning is 1,000. I want you to count how many zeros there are there. There are 1, 2, and 3 zeros after 1,000. So let's go back. All right, I realize your table is not in front of you, and hopefully you didn't write down that table. I'm pretty sure there's a note in Edpuzzle that says, do not write this table in your notes, because I will hand you a copy of this. So don't stress about trying to get all that written down. So it says here, conversion practice. Convert 1 kilogram to 1 gram. Remember, the kilo or the K is the prefix. That gives a value of something. And I realize that you could just easily some of you could easily probably just do this. You know a kilo is 1,000. And some of us are like, I don't know how to do that. So let's go ahead and start with the basics. I have 1 kilogram. 1 kilogram to 1 gram. I want to end in gram. I'm starting in kilogram. Now, if I have 1, I'm not even going to worry about the unit right now. If I have 1, the decimal place, where is it? That's really important that you know that, because I am just telling you I have 1 of something. I'm not telling you where the decimal's at. Every time you have a number, there is always a decimal there. Maybe it's not written in, but it's still always there. The decimal's always after the number. Always and forever. So if I say 1, probably not going to have a decimal. If I say 1.2, I have a decimal now to represent a different measurement. But the decimal is always after a number every single time. Let me go ahead and erase this really quick. All right, so 1. Now I'm saying I have 1 kilogram to 1 gram. So I need to know how many kilograms there are, or how much a kilo represents. So let's go back to the previous slide so I can show you how much kilo represents. Over here, I have my decimal place. If I have 3 zeros of something, I just need to move my decimal 3 different times. Okay, so it's going to be 1, 2, 3. In those humps, I'm going to fill in zeros. So now I have converted from 1 kilogram to a gram. And hopefully this is not confusing you, because I actually made a typo on this. It should just say 1 kilogram, 2 grams. Okay, so 1 kilogram, what I'm saying here is 1 kilogram equals 1,000 grams. All right, I'm going to erase that and show you the same idea over here on this next example. So it says 5 grams to kilograms. It's actually supposed to be, again, another typo. It's supposed to be convert 5 grams to kilograms. 5 grams to kilograms. So now we are going from a unit that has no prefix in it, so that represents 1, and we're going to kilogram. So that's a much larger unit. So we're going to a larger unit. So 5 kilograms, remember the decimal's over here. And instead of moving my decimal place to the right, which would make it a much larger number because I'm adding in zeros, I am going to move it to the left because I am going from gram, which is small, to kilogram, which is really large. So small to large is going to move to the left. So I'm still moving 3 places, 1, 2, and 3, but now I have 0.005 kilograms. So 5 grams equals 0.005 kilograms. And I think I'm really hoping this is not super confusing, but I think it is, and I'm going to work on this in class. I have this problem every year with trying to explain this. Anyways, hopefully this is a short video. Please make sure to ask me questions on Edpuzzle. We will practice this a ton in class. When we start measuring things, hopefully it'll make more sense moving the decimal back and forth.